So welcome to our third session about design pattern course. So here we learn how to build software with different patterns and how to adapt well-known design patterns that were invented many years ago to today's modern system. Also, I'm covering system design where it's possible. And let me first go to refreshing. So last session, we had observer and decorator patterns. And for people who joined our last session, could you please share with me if you remember when do we need the observer pattern? Okay, were they here? I'm going to call on you.
I'm it's just a pop-up thing that weather notification app. It should be one
Mhm,
of the example of observer design pattern, whereas like the weather server, which gives the update on temperature, wind, it
mhm,
it will act as a subject, whereas all of us are become a client or like the observers, which uses that uh, web server to check the weather temperature.
mhm, mhm,
This is one of the case of this observer design pattern. Yeah.
mhm. Thank you so much. So we use observers and it's coupled tightly with next level pattern, which is publish subscriber pattern. And it's used widely for notification systems. So observer you can use when you want your program to be observed. And for example, you collect metrics. How long does it take to send a request and get back response when you connect with database, for example? How long does it take? Which can help you bottlenecks in databases. So that's a very powerful thing to observe metrics from your application. Another one, how long does it take to call another service? How long does it take for my application to serve requests and respond? So that can help you to find bottlenecks and to put these metrics to observing systems. It's powerful to use observing pattern. Publish subscriber is next step from observer pattern. We use it a lot with message queues like Kafka, RabbitMQ. With this reference to system design. We also covered decorator pattern. And decorator, you can think about it as many layers above your application, above client, for example, on your application. They need to have authentication system, they need to have ability to circuit breaker on too many on unstable design, and also they need to rate limit requests when you go request, and all this could be wrapper around, for example, your HTTP or gRPC client. This is one of the appliance when implication of decorator when you think about it. And also if you go to higher system level, design level, um, in this case, we can think about decorators that we decorate our systems with API gateways that do authentication for us, that can do authorization as well, that can do rate limiting. They can also help us with some caching as well, but with load balancing, of course, with load balancing. And this is how we can decorate on a higher level, which is like system design level. Any questions so far on these topics? I wait for 1, 2, 3, 4, 5, and go next. Okay, creational patterns. So we reference to the book about design patterns, the last edition in 2020. Since then, I just remind you that a lot of things changed, and I'm going to share with you examples of today Java as well. But first of all, let's look at classic patterns. And if you go to the end of the book, you will find this diagram that say there is actually 5 creational patterns. And today I'm going to cover all of them. My goal is that at the end of today, at the end of the evening, you say, okay, I understand what creational pattern about, what it is, how we use them when we build software, when we write software, and also when we make services on high level. So yeah, if you would still have any question, please contact me. Please ask here at the end of the session, and don't hesitate to ask anything in the mail, in Slack channel, etc. Yeah, okay. So let's start with factor method. This is the order from the book, and what we're going to see in our book. So book cover a lot of interesting examples, and if you look at the example from this book, it will be Pizza Factory, where we start to create pizza. And the idea of this one that we start to wrap different ingredients, and we're going to say how exactly to create, and we basically aggregate all creators in one place. How it's applied to our real life. In our real life, when we write application, it's good idea to have single place where you start to create objects or functions as well, if it's functional, like if it's functional programming language. It's good idea to decouple your code base, your classes. And if you think about different languages, not necessarily Java, so Java idea is like to create a class factory. But if you go step up and think even about different languages, the good idea will be to have a special directory, special model, something where you say, okay, this single place where we create everything that we need inside our application. And what it could be, if you think about real world application, it could be connections to database, classes, objects, functions responsible for database, for serving your services. It could be the same for HTTP network, something like servers that's service connections. It could be, what else it could be? It could be if you have gRPC service as well. So it could be also a place where you create all configuration. You just put it near your factories, configurations, again, configurations for different connections to database, etc. So the main point from this, when you have your application, try to keep house clean and put everything in one place where you create all of these things. That will give you better visibility for how you would work with different services that's created in your application. Yeah, okay. This is class diagram that you can find for Java. And the idea of factory method that it defines the interface for creating an object. And in this case, you also can do different, yeah, the question from the question.
Are you sharing your screen or something? Like,
Okay. Wow. Thank you for letting me know. Oh, sorry for this. Okay, let me start again. But also let me do next. I think that's okay. Wow, you made it earlier. Okay. I'm sorry for this. So let me do next because I spotted. Do, 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 do. Yeah. Uh, just one more moment because I want a little bit. Yeah, this one, a little bit more updated version as well. Okay, sorry for this. I hope it's worked and let me restart recording because, yeah, okay, that's fine actually because I heard a lot of ideas. And yeah, okay. I was focusing to see you that much. I forgot to start actual presentation. So, let me also share a little bit about myself. It's in my presentation. So, I'm today lead software engineer, and I worked with a lot of different companies, a lot of different, completely different tasks to serve for a lot of requests and response. Today, what I'm sharing, it's entirely based on my career experience. So that's only about my career experience, so nothing else. But I hope that you can learn from me a lot. So this was slide when I was actually asking about patterns, and with this where you can see 5 different creational patterns, which is singleton, builder, prototype, abstract factory, and factory method. So we start with factory method, and I hope now it looks better when you see actual slide when I share about factories. Yeah. This is a class that create different pizzas. And when I was talking about configurations, for example, you can imagine the class that's responsible for different configurations as well. Factory method is actually engage you to define interface for creating an objects, and let's classes decide which class to create. And which is means that subclass may decide how exactly to do this factory method. Today, because we have also a lot of powerful functional programming, we can relax even much more this pattern because we can use lambdas to allow us to understand how to create, which is will be factory method. Now, today, it's very popular to use lambda as factory method. This is implication for today's. And let's go to abstract factory. So when we say that factory method allows us to define the way to create it, the factory actually, that's the place where you create, and you put lambdas there in your factory. So the example from book, I liked it because I never thought that you can do absolutely different pizzas in into towns, but also I liked it because again it's really easy to memorize. We are going to talk about pizzas, and the idea here is that it could be different factories in different cities, but they have similar interface. How exactly instantiate pizza? Idea here to reuse that if you set repository to connect with database, you may use this pattern because you create different for different tables in database, for example. Yeah, you create different repositories responsible for this, and they all have similar methods, but they have different implementation. How exactly you would communicate with database with repository? So they are example of factory. I widely used it in my experience when I didn't use any frameworks like Spring frameworks to connect to data, and when I need to write in plain language to connect to database, I would like to, well, basically I love very light frameworks where like I actually have a lot of control how to interact with database. So to establish connection, to close connection, to work and manage sessions. That all could be in interface factory. And then it could be implemented for different repositories with different names because it's like different name of different tables. And that's how you can meet this pattern in real life. You also can look how popular frameworks implement it, and under the hood, they use this pattern, factory method. This is more close to life diagram of classes. If you learn exactly Java and exactly want to understand how class is bounded here, you can use this picture. I found it to be a bit better than the one from the book. You can use this one. So factory provides an interface, and then you can create family of independent objects. Okay, so now let's look at repositories so you can see better what I was meant by repositories. So here I'm using also powerful concept of generics, of putting the type to repository, which will be product in this case. So product repository, it's implement repository. And I said that repository could have any type. In this case, repository, we call it parameterized by type product. And when I write methods from repository, because I parameterize it with product, my methods will look, they will be designed specifically for product. That's how you can meet it in real life when you work, like, for example, with databases. So that's similar example, but user repository. So you see, if find by ID before was this product, now you use user to find someone by ID. And when you save your user again, like you see that's now you use user. And now repository factory. So basically we create our repositories here, and factory method will be get repository. So when you create your service that's going to work with repository, you will use method get repository, and you just say, for example, product. You can say product.class because with it, like you can say just product, but why you can say it in Java? Because we have powerful mechanism in Java to work with classes. And because of it, we can basically say that we have an object that's describe our class. So that's, I love this example because it shows you how powerful it could be when you apply pattern to language. And it's not necessary to be a diagram from the book, because if you try to create a diagram from this, it will be different. It will be not the classic diagram that's shared in the book. And this is something I also want to take with you. It's not necessary to implement pattern letter by letter, how like it's called in the book, or if you found about different patterns, system design, etc. You found article how it should be implemented, but you can do it in your way because languages always evaluate and ideas always evaluate to new things. So you can think about patterns as a concept, what the idea of the concept you can use, and then go and see how you can implement it in your language, for example. So this is an example how Java can use the generic typization and the ability to describe class with special object, which is that is called class. Yeah. Okay. Now let's go to this pattern. Now I'm going to be a bit more interactive, and I'm going to ask if anyone heard single one. Could you raise your hand? Yeah, I see. Yay, yay. Cool, cool. Um, Anyone brave enough to explain what singleton mean? What this pattern is about? Yeah, Irina, Ariana. Yeah.
I think if I'm not mistaken, it's a while that I used it, but it's that you have one instance of a class so that you can avoid constantly recreating the same instance.
Mhm. Perfect. And that's correct. So singleton, powerful concept. Why it is important? Let's think again about repositories and databases. When we connect to database, we need to establish connection. And for application, whenever language again you're using, not necessarily Java, but it's very important to create one single connection to your database and operate with this connection. Uh, Otherwise, another thing that could be done, you could create connections and again and close them or left them open, etc. But that will be mistake because then you couldn't use the same session, you couldn't reuse them. In this case, singleton is very important. So for any things like this, like management of database, management of connections and sessions, for any things like this, it's very important to have singleton. It also became popular to use singleton for pretty much everything you have as services in your class, which is mean when you spin up server and you create HTTP connection or socket connections or again gRPC connection. It's also important that it's all will be singletons that hold these connections. Okay, let's look at example in our book. Again, I liked it because when you go through this mentally, you easily understand what's going to be a problem if you wouldn't have a singleton. So they created chocolate boiler. And again, if there will be few chocolate boilers, the one object will start to boil, another one start to boil as well. And at the end of the day, you will have spilled chocolate everywhere. This was example from the book. And that's the idea is that if you wouldn't use singleton for things where it's very important to use singleton, like connections with databases, you may ruin your application. You may ruin a lot of things. So it's even dangerous. That was the idea, like about chocolate boiler, because like it's dangerous when you don't use singleton. It's important for programming in Java because you easily can create object whenever you want. Not only Java, but any object-oriented language, and also with functional languages. It will be as well as important because you may create few functions responsible for the same thing. So you still should think about singletons in this case, but the paradigm will be a bit different. And if you're from purely functional languages, just hold tight because I will come to always creational patterns examples for Python, and you will see how they change when we talk about Python, for example. And as I said, keep in mind concept. Do not think too much about exact objects and diagrams. It's good exercise to go through them to understand them as well. But if you come in here from purely functional languages, don't stress a lot or think about concepts. So singleton ensures a class has only one instance. Again, it will be the same for critical functions. We should think very importantly that critical functions wouldn't be reused, which is also about configurations, etc. So we should, a lot of things we think about them as singleton. So repository factory should be singleton, and in Java by using a Java language and keywords, the very straightforward thing is to say This is private static final instance, and that's it. This is make sure that no one, when you spin up application, no one ever would be able to create another object because it's private, it's hidden, and also you create it when you start application. So you can play around with concepts like, okay, which things created when I start application. If you use another language, you still should think and can think about this way. Yeah, as I said, database connection objects, configuration objects, resources. Okay, prototype. That's pattern can be using a lot, even when you work with Java. And I'm going to go with builder as well here. First builder and then prototype, sorry. So builder, builder created to build objects in Java because you could create constructor, but then, for example, you create a product and this product have few things like color, price, I don't know, size, etc. And in Java, it's powerful. It's like a habit to use constructors to construct it. However, the problem is happening when you start to add new fields, which could be, I don't know, now let's add, we have color, price, size. Let's add manufacturer, so someone who created this product. And we need to create a new field to describe our object. And then we need to create new constructor, and the previous one should be deprecated. So builders solve this problem because instead of using constructors, you don't use them at all. And for this example, let's have ID, name, and discount. It's also product with discount. So when we want to add color, size, etc., we just add them to builder, and everyone who build our objects before, they still can build our objects without colors, and everyone who will use new version of our application with colors, they just add, let's do now new product with color, and that's it. So, for example, this is what when I saying about constructor, this is like this, or we can say make of car, model of car, etc. And this is our constructor. But if we use builder, we can do it like this. Again, this is very powerful when you don't have as a way to manage your data objects. You remember maybe that if you've been in first session, I was talking about data-oriented programming. Luckily, right now, a lot of languages supporting optional fields in constructor, something like this. So whenever you add it to constructor, now it's backward compatible. So you just continue to add new fields. This is more like how it was before, but again, from my experience, I was using builder pattern a lot everywhere. So before Java came with very new features in last versions, this was my favorite ever pattern to use builder, because then I could, you see, like it's much more extendable, it's much more flexible. So what is the main idea from this concept? Like if you think about your data objects, even you have things to be, as we say right now, optional parameters, go quickly with compiler, etc. The idea here, like whenever you have data classes, whenever you have all of these, always think how you will extend them. Always think how you will add new properties, how you will add new fields, etc. So things in advance, how it will be flexible in your program. even now a lot of languages support optional fields. Still, the idea, like, think how you would build the object so every client can build it easily for you as well. Okay. So when this pattern have a classic diagram that came from C++, but I've put there a few things that you don't need in Java. You don't need an interface. You can use static inner class. That's if you want to go with Java and go deep in my example. And the public static function builder will give you an object. Okay, prototype. So for this, I was thinking a lot about this pattern before I realized it was invented for languages who didn't have method clone, but Java already have method clone, which is prototype. That's all that you need to know about this pattern. Prototype giving you tools to create objects. And in Java, it's implemented under the hood by using powerful methods copy. If your language support copy that's smart enough to carefully copy all fields, etc., this is prototype. So in this example, this is actually an important example because it's not only how we apply prototype pattern with method copy. So this one, using builder, copy object under the hood, etc. But why it is important? Why this example is actually important? You can see here that the product as model responsible for updating itself with discount. Even like today, you may want to use builder. The concept of model responsible for their prototype, that one is important. So what I'm trying to explain, let me know if you understand it. But you could say how exactly set discount, not here, not inside product, but outside of product. For example, you have product service, and you say, now I'm going to update it with newer discount. And you say, I know how to build it with new discount. So I'm going to create new product with copy of previous product and set discount, but you can do outside of this service, right? So why is this example important? This dictates that's good idea for model where you describe it. It could be model that's responsible for product. It could be something else. But exactly this place responsible for updating itself. Model is responsible updating itself. I hope it makes sense. It means that you're trying to like delegate this responsibility only to model, whatever it is, product, item, user. So only user knows how to set new password. Yeah. So this is how I would share how you can think about good design. You can bound it with prototype pattern, but you also can sell it as a point like this will be cleaner design. Only model responsible for this. You are not going to do it anywhere else. So product service just invoke update discount. Product service wouldn't do like copy, set discount, etc. It just will invoke update discount. And update discount, how exactly you will do it, it's hidden. And in Java, I use the keyword private. So copy could be only done privately, only inside product. That's why you couldn't copy outside. That's it. That's how you can segregate it. Okay, I hope the idea you could took it. Now, let me share if I write function main, that's how builder and prototype will looks like together. So we build the original product, and then we just say original product update discount. This is what I mean when I say segregate for model to be responsible for updating itself. Product responsible for updating itself. This is important, and this is one of the very cool design practice that you can get with you. Okay, now, thank you for holding to this point. If you didn't touch object-oriented programming languages, because we come to the point where we're going to revisit all this classic pattern. Again, I heard in first session, they started with C++, object-oriented programming. They came to Java, but in Python, it was already developed with full support of functional programming. And also Python have concept of module. So basically, scope of visibility, it's coming with models. So now let's look at Python. Now, I already asked the question in first session. Could anyone tell me who is first-class citizen in Python? Oh, who first-class citizen in Java? Okay. You can Google quickly. Okay. So first-class citizen mean this is about language, how language has been developed. And this is like what was a fundamental idea of the language itself. So I'm talking about different languages, object-oriented programming languages and function-oriented programming language. You can say like this. So when we say about object-oriented programming languages, first-class citizen is object, which is mean you can't create function unless you've created object. I see your face. It's amazing. Now you remember. Now you remember I was talking about this. Yeah. So first-class citizen mean like where you start your program, what will be the most important point for compiler, or not for compiler, but when operation system execute your language, because at the end of the end, it's coming to instruction to execute your language. So how exactly to treat it? Interpreter, yeah, this word. So for interpreter also understand how to work with this language. Also, I can say that you can't develop language, just language. You need to develop either compiler, either interpreter, you need to do these two things. You say, this is my language, and this is the way how operation system would execute instructions. Turned from language to operation system, and someone in between could be compiler. For example, in Java, it's also Java machine. So it's compiler and then Java machine who get compiled code and say to operation system how exactly to execute. So first-class citizen in Java is object. It's forever object because it was the fundamental practice, how it was done in Java. They created anonymous objects, anonymous functions, and that came with powerful Lambda language where you could start to use object as functions and where you kind of could create finally functions without having any objects, but they are anonymous, anonymous objects, something like this. And in Python, it's actually both. It could be function, it could be object. You can create both of them without each other. So that's powerful. And for example, in pure functional programming, first-class citizen is function. Few more examples. Scala is this new language, and language developed to be able to execute it with Java machine and go through compilers the same as Java, and basically to be compiled in code that can understand Java machine. So at the end of the day, it's Java code, well, compiled Java code. But they wanted the most to fix the inability to have functions without objects. So they put both things to be first citizen for language, which is Scala. And Kotlin done the same. they've done the same. They also said we're going to develop language that will be understood by Java machine, but it will support both functions and objects as first-class citizen. And again, all this happened in many years after Java already came to the market and Python came to the market. And people were looking at different languages and they were looking like, okay, I actually left this and this and this from this language. So at the end of the day, when we look at languages, they all develop to be, very handful, very useful. And that's why right now it's a lot of support of different things in Java as well. Yeah. This is a slide that explain first-class citizen. So you can go to this again and again. This is like, also it's not only what you can create, what you can assign to a variable. Like in Java, you could not never ever fundamentally assign function to a variable, while in functional programming, yes, you can pass as argument, for example, function, yeah? In functional programming, you can pass function as an argument. This is powerful from the perspective of object-oriented programming, which doesn't have this idea, and return a result and store it in data structures. Yeah, so Java was fundamentally developed as object-oriented programming. So let's go back to Python. In Python, you create class doc. Then you say which is one, which is second one, and you can print doc. And you can do whenever you want in scope of one model. You didn't have to create class to assign variables to doc, which is how you treat Python as object-oriented programming. But Python also can have functions. And in this case, you create grid as a function, and then you assign it to a variable. And then you can execute it as a function, and you can pass function as a variable. Again, like from the perspective of object-oriented programming, that's very powerful. Also, I also had big troubles when I tried to switch between Scala and Java because I had to apply absolutely different style of programming in one language and then switching to another language and then switching back. That was pain, to be honest. Now I feel better because I just have much more years, many more years of experience. Now, when we look at these examples, we say that, again, Python is both object and functions variables. You can do whenever you want. Now, some design patterns could be used in bursts, first-class functions, and first-class citizen separately. So that's question that's coming to my mind when I think about languages. And now let's think about creation of patterns. So again, why emphasize on it? They for objects, right? Now, if we have functions, if everything can functions, what are we going to do next? So let's look at the answer. So some patterns, we think that it's easier to go for both paradigms, and they are strategy pattern. That was first session, observer, command pattern, template, method pattern. We will cover them as well. Chain of responsibility. Now, there are some patterns that could be used only in functional languages. For example, carrying. For example, compositions on functions. The pattern of monad. And again, you can argue if you already know Java that optional is something like monad because you can transform them, but it won't be like absolutely the same. Now, we can complain that factory, singleton pattern, prototype, builder, they are object-oriented only patterns, because if you have already a lot of powerful functions, It's you just don't need all this complexity. So basically, you're very lucky. Now, I was searching about Python a lot, and I found this website. This is the source. I will share with you in Slack as well. So they analyze classic patterns and they think about it. Okay, what exactly we have in Python? And at the end of the day, they say, we actually have the global object pattern. This is our pattern in Python. Yeah, I see. Nodding. Yeah. So as I said, my goal today, at the end of the session, you say like, yes, I know what they mean. I know that what creation of patterns, their concept and idea about. You don't need like understand diagrams or understand them letter by letter unless you really want to go deeper to exercise for yourself as well. So what is global object pattern in Python? It refers to a pattern where a single globally accessible instance of an object used through the model, because if you try with Python, you will see that it's have a concept of model. So it's basically, it's simpler because it's a leverage Python model system. So let's think about it, how I would implement configurations in Python by using global object pattern. I would say this is my config. This is set connection to database. As I said, it's very important for connections to database. And we use config to connect, and then we have function main. Now let's think about repositories. We create, okay, this one we create as configuration as global instance. This one is important. It is global instance. Now we have another model. We can think about models. It's .py product repository. And here I say we also may have base repository because I love object repository and I love the idea of inheriting and interfaces. This is how I would write. And this will be base and that will be product. Why I would write in this way? Because I would like everyone to follow the same notation as base repository. Even they could do it absolutely different than Python, and anyone can. No one can deprecate this one, but it just will help us all to have the same notation for methods. That will be get all, and that will be get by ID. Because otherwise, if we wouldn't have base repository, I can say my product repository get all and get by ID, but my colleague can say his, let me see which one next, user repository get not by ID, but I don't know, get by identificator, something like this. This is why still I would go this way. Because in this case, we wouldn't say like different get by ID and get by identification or get by UUID. However, like no one would stop you to do this in Python. Still, the concept of having common interfaces, it's a powerful thing, and you can think it's for any languages where you can do this. Now, as you see, global instance for product will be product repository, and that's defined only in this product repository Python. And this is main, that's basically will import it. And that's user repository, that will be like global instance of user repository. This is kind of singleton pattern in this case. And again, here we import them, and this is how we create them in singleton. That's it. We import them. But again, this is how you can see and recognize the same pattern by using absolutely different language and absolutely different notation. Okay, product and builder and prototype. So as I said, it's very cute. You don't need anything. You just can create discount expiry date when you want to add, for example, discount expiry date, and you just say like, for backward compatibility, it's null. So that's new field, but nothing nothing broke. Nothing has happened. We just added new field. There is no need for builder in the same way it's represented by Gang so many years ago. There is just no point to do this because language already supported. So language already powerful enough. So this is also takeaways that you can get with you. Like sometimes we work with languages that's powerful enough, so we don't need anymore this classic of patterns. Clone method. Again, we just said if you want to have new discount or not, and if you want to add discount expiry date, we can just add it whenever we want. What I didn't put here is that even so, if you want to update discount, you will put it inside this class. That's what I wanted to share with you as good design pattern, even not like classical pattern, but in general, it's good design pattern. Only product will be responsible to the way to update discount. If I come back to this example here, this is how we use all of this. So we just say, okay, this is against the idea that I shared with you. You shouldn't allow to clone. You can make this function to be closed and open only ability to update discount, because this one is not good design. But now you see how it will looks like in different way. Okay. Yeah. 1, 2, 3, 4, 5. Okay, now all patterns together. If you think that now you can also use a bit different ways to create an application, you're also correct. For example, if I wouldn't use any frameworks and I will build it in plain Java, I will use new shiny records, but I still would benefit from factories because I would love to create everything in one place. However, if I would use Spring Framework, I will use annotations to create a lot of things. To create service, I would use annotation service, and to create anything else, I would use annotation bin, even for configurations, which will be factory methods. If you think about it, like what pattern it is, just one annotation can give you the pattern under the hood. Implementation, it's like kind of the same that you get it from language, you also may get it from framework already implemented for you. And yeah, that will, under the hood, it still will create for me factory. It will create for me abstract factory, which will be the factory of all beans, all services, whenever classes I wanted to create. And I can even create a function, which will be factory method. Then I can mark it as bean, and then it will be abstract factory, well, not abstract, particular factories that will be created. That will create all these instances for me. Just it will happen under the hood. And if I look, that's very interesting idea. If I look at compiled code, I will find I will find these patterns to be implemented for me. But now I can delegate it to frameworks as well. Yeah, and if you, as I shared in Python, you will use different things. And yeah, if you want, I can actually look in your favorite language how you would create this as well. Okay. Yeah, thank you for sharing Refactoring Grow. In some presentations, I also had slides for this, like referring to this one. And again, you can find a lot of designs, ideas on this, which will be a lot of like object-oriented programming and also in different languages. So you can find different ideas as well for your language, for example. Okay. Now, do you have any more questions? We almost here. And again, with this books, we now go for the latest ever edition of Design Patterns. And on this moment, I want to thank you for listening to me today.